It's DUG24. 24 hours, 24 sessions, 24 speakers, 100% Microsoft Dynamics. It's unparalleled, unprecedented, and undeniable fun with your hosts Beau Schwieso and Bobby Small. Let's get into it with another episode of DUG24.
Feeling, Beau? I was looking for a great meme, but we are, just so you know,
halfway.
We are halfway there. You know what I'm talking about. If anybody wants to jump off and sing with me. Whoa, whoa, I'm halfway there.
I'm not.
We are living on a prayer. Still feeling pretty good. It's still early enough. It's it's within reason. But this next stretch is going to be interesting.
Yeah, I mean, honestly, we just blinked through the first 12 hours, so probably will happen the exact same way in the next 12 hours.
Yeah.
I do feel like I'm losing my voice.
It's great content. I am wrapped. I mean, I had a couple things going on, and obviously grabbing food here and there, but it's been great content. I've been excited to see just this variety of content, and like I said, we're only halfway there, so 12 hours more of great content.
Yeah, somebody reminded me that I ordered a bulk order of chocolate and asked if I had broken into that yet, and that reminded me that I had chocolate in the other room. So
chocolate and chomps. So I'm guessing that's what you have sitting by.
I ran out of chomps just yesterday, so I bought chomps specifically for this, and then ran out. So what I've eaten today is espresso, one shot of espresso, and a Hershey's bar. So
that's
the
not
pinnacle of health.
Yeah, you need to grab
right
something, to pull you through the evening. You have to have
Probably.
a big, next segment. You just have a big bowl of spaghetti or something, or steak. Cool. Well, we've got our next presenter on tap, ready to go.
Nate.
So Nate's sitting here ready. Nate, come on off and join us, buddy.
Hey, how are you?
Good.
We're doing well. Yeah.
Let me.
Did you have any hat
stuff?
requests? I can see what I've got lying around.
Fedora.
Not really. I didn't know we were doing hats.
Both said I'm wearing a cowboy hat for Rob's, and I said, yeah, of course, that makes total sense.
Yeah. I don't think I've ever seen Rob not without a cowboy hat. So
or his Lone Star shirt. I say if he's not wearing a cowboy hat, I can't think of a time. Maybe he was playing hockey. If he's playing hockey, I don't think he has a hockey helmet that is also a cowboy. That'd be a pretty cool looking hockey helmet, though.
yeah. Is hockey big in Texas? Because hockey. So I'm up in Michigan, and hockey is much more popular.
But it's he's a big hockey fan, so I don't know where he picked that up. We have to ask him next time. Or if you're still on, Rob. He was going to grab a beer. I think he jumped off, so we may never know.
Hockey is actually pretty big in the Houston area, so I believe it. Yeah, I think last time I asked Rob, he's from Houston, so kind of
And his email is Hockey Rob. His personal email is Hockey Rob, so he's definitely a big fan.
Oh, all right. Well, up here we just import all of our hockey players from Canada. So 30 minutes away from Canada.
Yeah.
We need to do the same thing for the World Cup.
Didn't we lose to Belgium?
Yeah, we don't talk about that. Yeah.
Well, I'm ready to go.
Yeah, you're ready to go, man. Kick it off.
We're ready when you are. Yes,
let's
sir.
Jump in. Let's do it.
All right. So what I'll be presenting about today is, I call it from idea to production, how we can go from a single change set all the way to having code deployed in production, and use a lot of the new stuff that Microsoft's coming out with, plus some old tricks we've just sort of forgot we had, to have a much more reliable and automated pipeline of just getting any of our customizations out. So this is a presentation that I wrote and was going to present in Slovenia, but then life happened and I couldn't quite make it. So Lane contributed a little bit. He actually did the presentation for me. But I did want to call out just sort of two things. Everything that I'm talking about, if you hit this QR code here with your phone or go to this link, everything I'm talking about, we have supporting documentation or pipelines or some technical artifact for whatever it is we're talking about. So if you're like, hey, that sounds great, I want to go do it, it's all the source code and all supporting material is here. So if any of this sounds great, we've got all the tools out there so you can go build this in your environment for however you want to do it as soon as you want to. But I'll introduce myself. I'm Nathan Clouse. I'm a senior technical architect with HSO. I'm based here in the United States, but HSO is a global company operating on, I want to say every continent or thereabouts. So global reach, but I'm focused in for US and global operations. So I've got sort of some questions. I'm not sure I'll be able to see chat very well, but just maybe show of hands or just ping in the chat. How many of you have ever deployed something to production where you weren't 100% absolutely sure that was the same set of code that passed the last round of testing? So I'm not sure if I can see chat.
I think shocked face means yes.
Yeah, I think there's a couple reactions coming in, some thumbs
Okay.
up. So you got, I raised my hand, so you got a few people.
Okay.
I've got a cowboy hat, Nate. I've definitely turned it into Wild Wild West. So yes.
Yeah. Yes. Most technical people do have an honorary cowboy hat for some of the stuff we've done, especially in the past with 2012 and 2009. Okay. So there's some there's reactions out there. One of the things I want to focus on today is, like, I call this, the promise. It's one artifact. We create it once, we tag it once, and that gets carried forward through workflow, through environments, and we know exactly where it starts and where it ends in terms of what went into it, what environments it went into, what testing took place. And did it get deployed to production? Did we decide to, kick it out because it had a bug? Did it stop in UAT? And we issued a bug for some feature that was added. Just having absolute certainty of knowing where our code is down to the change set, matching a individual change set to a particular environment. What we'll cover today, I call this immutable packaging. So we create a deployable package, a binary, just in general terms, and how we can durably version that throughout the entire process of where it could go, where it could end up in the next stage of its life, and how we can promote that through all of our different environments that we may have. I'm going to focus on an implementation set of environments that you may have, including a gold. But for any of these environments that don't apply to you, feel free to, sort of in your head, remove them or put a different environment in for a different purpose. Also, how we're going to cover structural enforcement. So this is not just managing code, but managing individual binaries with DevOps. And also full environment automation via PPAC. So some of the new stuff we're getting from PPAC, we can spin up environments, do database restores, tear them down, all with automation on demand, so long as we have the storage. And just as a call out, what we won't cover today, X++ design patterns or just source control patterns, specifically Dataverse solutions or Power Platform ALM in anything other than broad terms. So we're really focused on just the finance and operations portion of the PPAC set of APIs. But those are slowly merging together, and we will need to have a more comprehensive solution in the future. But we're going to start with sort of baby steps. So looking at the big picture, there's a few areas I want to focus on. So here on the right-hand side, we have sort of just an example of some automation that we could do. And this is up here, we've got our triggers, but focusing on just this right here. When we get a pull request to main, and we're going to focus on a get experience, but we have some event that happens and we want to do some automation. Pull request is a good example where we would take a set of changes that occurred, do a build, put together an environment on demand. So provision an environment, copy a database into it, do the deploy, do the database sync, run any kind of automated testing or manual testing, and then do a teardown, and we take that event that happened and give it a pass or a fail. So if you're unfamiliar with what I just described, I'm talking about in non-functional or in functional terms, someone said, hey, I've got a new thing I want to roll out in terms of new code. Here's the process it's going to go through, just in terms of environments for what we're going to do with it. And since we talked about, AX 2012 and 2009, this database sync, is still important because it'll catch stuff like, if we changed the data type on a field, but didn't change the name. So there's just a lot of value here, and this can all be done via automation. So if you look at other offerings that we currently have, this is something totally brand new as a option for us in X++. If you look at other languages like C#, they've had this for a while, so we're playing a little bit of catch up. But also here in this area, environment provisioning. You can build a pipeline that you will just put values into to provision your environments in a particular way with particular add-ons enabled. You can sort of imagine what you want this to be, but you can fill out, just start a pipeline, fill out what your values would be, click go, and that'll run and provision your environment, do database backups and restores, provision a particular, branch of code or tag of code, whatever you want it to do. But that's just something new that we've never been able to, really have before. And also call out, if I want to spin up 10 dev environments, just sort of click, get 10 environments. I can do that, and I don't have to worry about vCore quotas or any of the Azure stuff. I can just get dev environments. Across the top, we've got all of our common triggers. So these are things that we would routinely use to turn on or activate some automation. There's a lot more out there, but these are just really the ones I focused on. There's a push to a release branch, really just pull requests or any type of commit. I'm using the word push to mean commit in this context, but really any kind of change that gets pushed into any kind of branch on the server. And then this is really what I want to focus on. And this is, sort of excites me a lot in that we can now from start to finish down to a particular build version that could be, 6 digits long, say exactly where it built, where it is, what testing took place against it, how it was merged, who approved it, all the particulars of where code is, which is a feature we've not necessarily had a great track record with historically. We've done a pretty good job, but now we can do an absolutely perfect job. And when we look at this, we can do a code push. So, if something gets, some new code gets added to the main branch, we do a build, compile, we get a package, we publish that artifact inside of DevOps. Then we push that artifact into particular environments with some automated testing of our designing goes in there. So I can take this code package, let's call it version 100. I can push version 100 to UAT, get some feedback on testing, say, hey, that was good. We're going to push version 100 to DM. Hey, that went well. There's nothing really to test there, but we didn't break anything in the, at the same time. If that goes well, then we can push it to our gold environment. And then if that, goes well, we get approval and deploy it to our prod environment. And we can design this to be whatever workflow you would like. This is just the one I put together. But you can build your pipelines such that whatever you want, however you want it, with whatever kind of approvals, we can string that together and it'll just automatically happen rather than someone has to click a button in LCS in order for this thing to happen or this other thing to happen or, something of that nature. Why LCS can't get us there? This is probably well known, but I'm going to cover it anyway. First of all, I hope that people know that LCS is going away. Hopefully that is not news. It's been on life support sort of for a while, but we're getting closer to LCS no longer being in the picture for our cloud first deployments. But LCS, we manually do portal deployments, which means someone clicking buttons. We do have some costs related to dev and build VMs of around $500 per month, sometimes more, sometimes less. But the LCS has its own asset library, which is managed a little bit differently than how our DevOps asset library may be. That's neither good nor bad, but it's just another thing that has some security constraints that a lot of organizations are unwilling to accept. So that makes it, in some instances, not something we can use, and it's something that is required for LCS automation. But also, there's no automated pull request validation with LCS. We can orchestrate deployments and stuff like that, but that's as much as we can do. There's no follow-up on that. And just in general, LCS is a portal. It's kind of slow, it's clunky, and we have very limited APIs. On the flip side, PPAC is API driven, which means we can use pipelines and triggers and any kind of automation that we would like. One of the things we will need to address, which is unpleasant, but it needs to be talked about, when using the PPAC APIs, they currently are interactive, which means it will eat up your hosted agent's minutes. So you will have to buy one. Typically, they're $40 US per month, MSRP. But that's a very small price to pay to get a lot of automation opportunities. Otherwise, you will run out of minutes fairly quickly. But with the build agents and the enhanced capabilities of a hosted build agent, with DevOps, we can have one artifact that flows all the way through the process untouched. We can do full integration with any kind of testing tools we want to use or set up in our pipelines, and we can orchestrate everything such that different resources can just do their jobs as normal. People can push code, people can do a pull request, I can approve a pull request. And then automation takes it to the next step. I don't have to worry about oh, this is approved. Now I've got to schedule a time at night in the evening to go into LCS to actually push this to UAT, so I don't bother anyone. Automation can just do that for us when we tell it to. When looking at LCS versus PPAC, when looking at the basic flow of how we can manage our binaries. So we've got our hosted agent, can just move our binaries around using all kinds of APIs inside of PPAC, so we can deploy an environment and also check in on it. And Microsoft is a little bit behind on where they wanted to see this, but Microsoft is heading towards a experience where all of our F&O environments are sort of pre-staged behind the scenes, so we don't have to wait sometimes upwards of 6 hours in PPAC to get an environment. They'll have a blank one just sort of waiting for us. We'll deploy the code, do the DB sync, and get environment provisioned from nothing to ready for a user to log in approximately 30 minutes. That's still a ways away. I put 90 here. This is still probably pretty aggressive. But Microsoft is heading towards that. So if you're familiar with how we can get like a CE environment in just a couple of minutes, Microsoft's going to pull the same trick for F&O. But they're still working on that with the environment sort of pre-provisioning in a blank status. But when looking at LCS, you've got build VMs that sometimes, if you're not using cloud-hosted builds, those cost money. Same with your dev VMs. We have our NuGets still hosted in DevOps, but we have to push everything to our asset library, which requires an account that has MFA disabled, which is a non-starter now for most organizations. And we can orchestrate some API interactions to do deployments. but we do the deployment and sort of wait. We can't really check in as to what that environment may be doing inside of LCS, where PPAC, we can get a much closer idea of what it's doing. And if you use the Finance and Operations Management app, that'll give you even more detail as to what's going on. But lastly, the major constraint with LCS is you get your tier 2 environments, or well, really tier 2 plus, based on SKUs purchased. So production plus sandbox plus whatever SKUs you opt into. Whereas in PPAC, it's all storage based. So if I have storage to support 10 productions, I can have 10 productions. It doesn't matter. I just need to have the storage to support the workload. I don't necessarily need to have the SKUs to support that particular workload. So the immutable artifact, or just, I get one binary, I know exactly what it is, and I want to know where it goes. So how we build this, it's compiled from source on our hosted agents, so we wouldn't need a build VM. I think we're going to see build VMs go totally by the wayside, unless if it's an on-prem build experience. We have used NuGet to get all of our dev ALM packages to provide the tool chain, so it's all provisioned as part of a normal build process. There's no special software or build VM or image or anything like that anymore. NuGet is the path forward. We can get a version number sort of baked into the metadata at compile time. So if we have version 100 and that fails testing, and we do issue some new code and we get version 101 that doesn't present with that bug, we'll know exactly which one is which based on the artifact that we have inside of DevOps. And these are published, through a pipeline artifact. And then what that means is it goes into the DevOps artifact store with a version number, and it becomes sort of a known fact and a mutable artifact from this point forward. So that means we get the same binary that can be deployed to UAT, DM, Gold, Production, any other environments you may have. So we aren't guessing or hoping or making sure, like in LCS. I've got 3 different versions of the same deployable package. All the last number is .1, .2, .3. I'm going to guess it's .3. That's the newest one. That's probably the one I want. We're not going to be doing any of that guessing anymore. And why this matters, with that version number baked into the artifact or the binary, when we do any testing, automated or otherwise, we'll get that reported back to DevOps on that particular version. So if UAT passes but Gold fails for whatever reason, we can know with absolute certainty the reason why it failed is likely environmental, not a build variance, or some other change that snuck in there because someone else did something we didn't know about. It also allows us to do a rollback. So if we have a particular version that was known good, we could, in theory, deploy that known good version back to that environment and get it in a good state if it didn't break any data. If we need to just roll back to a prior version of the environment, that's there in PPAC too. Our auditors can trace everything that we're doing. That's becoming more and more important because there's going to be questions just from a IT global audit standpoint. So if we know exactly where our binaries are, what versions they are, where they went, what happened to them, what their outcome was, we can report that to our auditors. And anytime there's any kind of change related to that, so I call it cache invalidates on version bump, but when we get a new version, it starts out at the beginning of the process. So it doesn't, we aren't going to be saying, oh, well, this was a one-line change, so it's probably fine to skip all these other environments and just throw it in UAT and push it out prod. Won't be able to do that. I know that's potentially a negative in some instances, but again, we've got a version number that goes through all the steps to get it out the door, and we're going to lean heavily on automation to do the work, not people clicking buttons or doing anything like that for as much as we can. But this means that our compilation environment, or our build agents, is deterministic and versioned in everything that it does. So we have full traceability from start to finish of a change set, a pull request, and how it got to prod and everything in between. And to really sort of visualize this, same sort of thing where we have our artifact that gets created once, and the same binary from our artifact store goes to each environment, and it must pass validation in order to be approved for that same binary to go to the next environment. Meaning we've got the same version, same binary coming from a common store, but it is passing whatever testing we have in place to make sure it is good in a UAT workload. It is good for DM. It is good for gold. It is good to go into production. And we've got workflows with outcomes on every step of the process here. So hopefully that means no surprises. And I have later slides that talk about some of this, but we can schedule all the automation here. So this isn't just, someone did a pull request and just automation happens. We've got all kinds of workflow capabilities that are being added into DevOps for just ALM, but then those can be extended with whatever workflow engine you like to use. If it's Power Automate, we can do that too. You can do ALM on your phone if you really want to. But it's just more of a suite of tools to get our software, our SDPs, or deployable packages or artifacts, shipped out the door with as much sort of rigor as we can, and making sure that we're not inadvertently breaking something or, not following the established workflow. Branching and enforcement. So really just the key takeaway here is branch controls where the code can go, and pipelines control where it does go. So I'm not going to spend a whole lot on just Git branch modeling. That could be, I'm not sure if we have any people on here that have strong opinions on whether you want to use Git flow or feature branching or this, that, or the other thing. I'm a fan of feature branch, but I do mostly implementations. So there's no sort of wrong ideas here. It's whatever works best for you and your organization. But I'm going to focus on, feature to main to release with tagging. But what this means is we'll create a feature branch that is some new feature. So let's say I want to add three new fields to a customer for classification purposes. I add those in my feature branch. It goes to a pull request or a PR. We do whatever integration testing there would be as part of that pull request accept, and it goes to the main branch. Then from there, our main branch would collect any set of features we want to group together. And then we'd merge those into, or pull those into a release branch, and that could be 3 other, features that we decided to group together. Then we build that and deploy that to our UAT environment, our DM, our gold, or prod. Again, following the same workflow. So that's really how I envision it. Again, there's no wrong methodology here. It's whatever works best for you. And if you want to just do feature to main to, UAT environment and carry forward, that's fine too. But every, pull request runs, in theory, runs a full integration test, whatever that means for you. But the key idea here is we're going to spin up a new ephemeral sandbox, so a new temporary sandbox just for that pull request. We're not going to throw pending code into any of our established long-standing environments. We're going to spin one up just for whatever it is that we're doing. Do whatever operations we want, copy the database from a known good source, deploy the package, do the DB sync, run automated testing, run any non-automated testing, report back what those are, and then tear down the environment when we're done. So if you're familiar with C#, really anything Azure, what I just described, where we spin up a test environment, do some stuff, get a result that we're interested in, and tear it down, that's not too groundbreaking. This is sort of a new feature for us in X++ in a way that where we can do this fully automated with PPAC. So this is sort of a new way to think of our environments. So our dev environments, especially our UDEs, spin up when you need them, get rid of them when you don't. All of your work should go into source control, Git or TFS. I'm a huge proponent of Git, but whatever works for you. And when we need environments for a particular specialized task, we spin them up on demand, throw whatever we need in there, get the result we're looking for, and tear them down when we're done. And we keep our long-standing environments around, especially prod. And those are, just artifacts of our deployment. But anything else, we spin up on demand and delete. We get rid of it when we're done. This is just sort of to walk through that branching strategy where we've got some different features that may go in, plus a bug. We'll do individual pull requests. Those will individually pass, go into main. Then we'll call a branch cut just to get it into a release. And then that release branch has all of our 2 features plus our 1 bug grouped together. And then we carry it forward in our workflow to get it into UAT, DM gold, and eventually out the door into production. Additionally, pull requests or PRs, they sort of automatically turn into a quality gate because we've got all kinds of automation hooks and triggers around a pull request. So we can do any kind of automation that we would like around a pull request before, during, or after it gets created or approved. So if someone creates a pull request is just a developer saying, hey, I'm done. I need someone else to review my work. We can use that as a trigger to kick off a build, code analysis, code review. We can send that to an AI code bot to make sure best practices have been followed for X, Y, or Z, or whatever they may be for your organization. But then what that means is every commit inside of that branch that makes it to our release, like let's say release sprint 12, it's been validated in some way because it had to go through a PR. Whether that's a manual intervention from a person reviewing or AI, doesn't matter. But something or someone was given the opportunity to review it, and that opportunity was taken, so we know exactly what's in that pull request, so we know what will go into that artifact, and we know what environment that artifact is in or will go in. And then UAT deployment is just is for business acceptance, not catching any regressions. So that allows us to move hopefully all of our bug discovery much earlier in the process. If you want to have different environments in front of your UAT to catch those, again, you design the pipeline that you want, and that's what we can use it for. And what this means is, our process that we had with LCS, where someone had to remember, turns into structure that can't be forgotten because it's all done through automation. So when looking at the PR validation flow, this is just again a visual of that. We do our build, provision an environment just for this this integration testing. You can call it whatever you'd like. We wait for it to provision and stabilize. Stabilize means make sure it's on, all services are running, anything of that nature. We copy a DB in, do a package deploy, do our database synchronization, do any kind of smoke tests. I included, like, we've got sys tests, we can do ATL, we can do anything with OData or mock, anything with RSAT, or name your tool. If it can be, executed in a non-interactive fashion, we can go ahead and include it here. Get the result that we're looking for, and then we delete that environment when we're done. We don't keep it around. This is just now just ordinary infrastructure, so we're headed much closer to a true SaaS model rather than how we've done in the past, where if you provision a dev environment, you keep it around for a few years. That's no longer going to be the case. So again, I want to just emphasize we got structural enforcement. So our PA, our PRs, our pull requests, as a quality gate that we must pass. So main never has any untested code in theory. Deploy only triggers from a release. So we don't ship main, we ship a release, which is a collection of change sets or features. Release change off of a deploy success. So it has to go through our workflow. We can't skip directly to production. And it's DevOps workflows, so that's enforcing that. Our service connections, so this dives deep into DevOps, but I'll briefly touch on it. Our service connections can only have or can have branch restrictions. So even if someone tries to bypass some of this, quality gating that we have up here and try and push main out the door to UAT, our service connections can have branch restrictions around that. So if someone tries to not follow the process is aware of what it should be and what is allowed, and it prevents that from going out the door if we don't want that. And then, production credentials are only issued to release branches, meaning, again, in our workflow, the thing that can do the deployment can only be aware of specific environments. So if our pipeline can only deploy to UAT, it only knows about UAT and only has credentials for UAT. But what this means is, the artifact never changes. Our binaries never change once we create them, only its fate does. So where it goes, where it ends up, who approves it to be moved forward, that's the only thing that changes. All right, so the deploy pattern. There's two ways we can do this. I'm a huge fan of the sort of submit and wait. That does chew up build time, but I just like to know that stuff's done rather than sort of fire and forget. So we have one job where we do a readiness check on the environment. So is it there? Is it online? Is Microsoft currently doing any servicing to it? Is it already in the middle of some other servicing operation like a PQU? We make sure it's there. Then we go ahead and deploy our package. And then we have our job inside of DevOps, just sort of sit and wait to make sure that it executes completely and successfully, and then report the outcome. So this can be 1 to 2 hours or 60 to 120 minutes of just, your build agent waiting, but then you get the true results as soon as it happens, rather than having to remember the operation ID and then, once an hour, check back on the operation ID and see what happened. Then after that, once we've deployed our code, we can do another job to verify. So an independent status check via some management API to confirm, hey, we expect version 100 to be in this environment. Is that what's truly in there? Yes or no? Then we can use DevOps to notify stakeholders of anything that needs to manually happen if we haven't fully automated that out. And this can gate downstream environments. So we can keep track of, a particular binary is now in UAT, which means it's sort of yellow to go to DM if we deem it's through workflow deem it's okay to go to its next state. Just a visual of the deploy template. Again, we're using Power Platform tools here. But it is important to make sure our environment is ready. Microsoft will, I learned this the hard way, will have your environment have some kind of servicing, typically after hours. And if you're running your deployments at the same time, they'll fail and you'll get some nasty looking emails, but it just means Microsoft was in there doing stuff that you didn't know about because they don't disclose when they're going to be doing stuff. So, just make sure it's in a ready state. You can wait up to 30 minutes, and after that, just cancel it and say, hey, environment was being serviced by, third-party actor or first-party actor, and try again later. But assuming everything is, good, again, we can verify everything with PPAC APIs and confirm that everything is in there that we would expect, and then our stage passes. And lastly, I've become a huge fan of using Teams messaging to deploy and just let you know what's going on, because this is going to be more sort of automation driven rather than anything else. And I know we all love our LCS emails, so we can include that. And I've got an example. I'm going to drag this over. This is my Teams. So here, although it's been a little while since my last build pipeline ran, but it said, hey, on 5/27 at 2 a.m., this automated build kicked off and it succeeded. So I don't need to check my email. I don't need to do anything extra. I can just have my ALM bot in Teams talk at me and let me know what it's doing, so I know what it's up to. So inside that environment readiness, again, always poll before you start deploying, regardless of what environment you're in, because this may not be known, but in a PPAC environment, we can only have one deployment going at a time. So if we have some Dataverse deployment going for some other plugin that F&O doesn't even specifically care about, that will block us from doing our deploy or cause it to wait at a minimum. So just make sure your environments are ready. And this is deploy when ready, when you get that signal. And without this, you just sort of get an instant failure, which again seems nasty, but it's just an email that looks pretty dire, but it just means something else is going on you didn't know about. I'm a huge proponent of the synchronous wait. The other style is I'll fire and forget. We don't really want to do that because we don't know if our stuff truly did deploy. And I always schedule like a 3-hour timeout for everything the environment may be doing with the spin down, deploy the package, do the database sync, and bring it back up. Usually it's closer to 30 to 60, but I always plan 3 hours. With branch triggered provisioning, again, this is just sort of another workflow. This is another pipeline that we can have configured. When we push a feature branch, we can provision that ephemeral environment automatically, deploy our F&O template, do our database copy. All the developer code can be done in there. And it really depends on what style of environment you want to make. So we've got 3 sort of distinct flavors in PPAC of environments we can have. We can have a UDE, Unified Developer Environment, USE, Unified Sandbox Environment, and UPE for Unified Production Environment. And we can have any number of those that we want so long as we have the support. I'm sorry, not support, capacity. And so when we create a feature branch, what this means is, let's say I've approved a design and it's approved to go to development. So I can make a feature branch for that. When I make the branch, I can have a pipeline that kicks off and goes ahead and provisions that UDE for me. And then it'll provision it to the person that the dev task is assigned to and make sure they're automatically added as a user. So again, we're automatically creating environments on demand, putting code in them, putting data in them, setting our developer up for success, making sure they've got a work item. So they're ready to go when that environment is done, when they get the email or the Teams message that says, hey, dev environment 123 is ready for you to work on work item 456. They've got everything they need. And it was provisioned 6 hours or less before they get the notification that they can start working. When they're done, they get a work area just for them. No one else is in there unless if they specifically ask for someone else to be in there to review stuff. They can commit their code, trigger a pull request, which is again them raising their hand to say, hey, I'm a developer and I'm done with my work. It needs to be reviewed. Once it's that PR gets merged, we can delete that sandbox and release the capacity or storage in PPAC and start this all over again. But that means there's 0 infrastructure specifically to manage. We have to manage capacity, but not infrastructure. But capacity gets eaten up by extra infrastructure. So they're different, but still related. For the environment lifecycle, again, just a visualization of this, but I really want to sort of talk about how powerful this can be for a developer, because we don't have developer environments we have to keep around forever and re-provision or reconfigure for a person, or like transition this environment that's been around for 6 months from me to Beau, and then Beau does his thing, and 6 months later I get it back. We can just create these things on demand for whomever needs them. So like on an implementation basis, if we have 6 work items that all need to be worked on at the same time, we spin up 6 dev environments, all devs do their thing, report that they're done. And then after that, we go through the pull request lifecycle. We can spin up an environment for extended testing related to that pull request. And then deprovision everything when we're done. We always, do a teardown of everything that's not in our specific environment plan. And what's in our environment plan is, in terms of long-term environments, is probably just going to be UAT, DM, gold, and production. And then after we're live, probably a UAT, a support, and a production. So the full development lifecycle. Once the developer pushes that feature branch, meaning we have work for a developer to do. We can create that sandbox, again, do all of our copies. But this, I really want to drive home, so I don't like this phrasing, but it's more that our infrastructure is cattle, so they're things that we manage sort of as a herd, and they're not pets. So if you've worked with like 2012 and 2009, once you get an environment up, it's yours sort of forever, until it eventually dies. We don't have to do that anymore. We can spin stuff up, in our herd as we need to. As we need more environments, we can get more cattle. As we need less, we can release those cattle. So our environments are disposable, and it really, code is the main thing that matters for this discussion, not really our environments or infrastructure or anything like that. One call out that I want to make sure is well known is we do have to plan ahead, because when we provision environments, they come pre-configured in a sense of what database we put into them. And then Microsoft does their cleanup scripts, which may deactivate some users, clear out some security role assignments, get rid of app registrations, this, that, or the other thing. So we do want to plan ahead. So, first, these are just a few things that we can automate. So, a DMF refresh when we bring an environment online after we've done database restore, validates that everything, like all of our batch jobs, are in a particularly known good state. And if not, go ahead and activate them. If there's any service endpoints that might be stored in F&O itself, make sure those are repointed somewhere else. So if we take a production database and put it in UAT, if there's any connection strings in there that Microsoft didn't clear out for us, let's say they're a custom field, we repoint them somewhere else so we don't have 2 environments that are pointing at the same endpoint, which is a production workload, or just in general reconfigure the environment to a set point. So meaning what batch jobs get enabled or do enable to run. Again, if there's any credentials or connection strings or anything like that, get those in there and correct them to what they should be. Enable users, do any role assignments, anything that gets your environment into a particular state so it's ready to go. We can now automate that with DevOps. And it's sort of significantly easier, especially with our database restore story, because we can just copy from source to target and we get sort of everything. So that means our Dataverse solutions, our F&O code, everything that supports that, plus dual write, and dual write does have a known thing where you do have to reconfigure it a little bit, and APIs there aren't necessarily the greatest, but we still have some tooling that we can use around that. But that means there can be, to the best of our ability, no manual steps between a copy and ready to use. So we can create a pipeline that just says take database from here, put it there. And then once it's there, we configure that environment to look like a UAT, look like a gold. And automation just takes care of it and says, hey, it's now ready, go sign in and double check everything. But a common gotcha, and I've got some documentation in my Git repo about this, the SPN has to be registered as an F&O app user in order for a lot of this to happen. And you do have to do a little bit of crosstalk between the two, meaning you have one sort of automation SPN in every environment, and so it can do this some of this operation up here without having to know specifically what user is allowed in there, since it may change based on source to target. So there's a little bit of variability there. Just plan ahead and sort of pre-provision your environments across your entire environment chain, and you'll be fine. In terms of governance, just want to call out, our branch triggers can can be used so that no unauthorized code can reach deploy. Our pipeline chaining, so it has to go through, stuff can't go directly to production, it has to go to UAT, be approved, and go on to whatever workflow you design. But we can chain those in there so that nothing can skip validation. We've got environment approvals, so you can have whatever kind of workflow you would like per environment. So as for instance, you need 3 approvers for something to go to production, and that can be someone in IT, someone in the business, and someone in compliance. And you've had a meeting beforehand, you all agree, this is ready to go, but now you're sort of rubber stamping it, and we've got an approval system that's keeping track of that. We've got service connections, so those can have connectivity to particular environments. Those can also be based on branches. So there's a lot of stuff that can be set up to make sure there's only one path forward in that workflow, and anyone who tries to outsmart it goes to just a dead end, and we have reporting on that as well. But the most recent addition I want to call out is this business hours restriction. So you can control when deployments can happen. So it's not just whenever anyone approves it. It can be, we can only deploy to production 3 hours on Saturday morning on Eastern time zone. You define what that is, and it'll wait until that time, assuming it gets approval. And if Microsoft is in there doing something, it'll say, hey, this timed out, couldn't obtain an exclusive lock on the environment. We're going to try again next weekend. But each layer is independent, and any single area can fail, but others still hold. So that's, I call it defense in depth. So it's not just one thing keeping everything together, it's multiple things keeping things in check. So should unknown actors be in there doing stuff, nefarious or otherwise, we've got checks and balances. This is just an example of what that may be. This is how I've configured it. So we've got release pipelines. We chain together our pipelines with approvals. So we can only go to DM, then human would review that, and they would go to the next stage. But if someone says, hey, I actually don't want this to go anywhere past DM, it's got an issue, it goes here and then it's blocked, and that's the end of its workflow. We can't bring it back. We've got to create a new artifact on a new version and walk it through the process again. And as you can sort of see, this green box down here is everything went well. So you can see it's sort of difficult to get to that by design, because we've got all kinds of structure around who can approve it, who did approve it, where did it come from, are we within our business hour window? If not, we queue it until the next one, or we deploy again on that Saturday morning. So a lot of, and this is sort of basic, a basic configuration, but there's a lot that you can configure for whatever works best for you. Just getting started. I have a link at the end, but this is all built out there, and we've got hopefully good documentation. If not, feel free to leave an issue on my GitHub, and I'll take a look. But we've got a build pipeline ready for you out there with hooks and triggers for PR validation. And this is sort of the minimum viable product for what you can do. And then you can tailor it once you've gotten comfortable with what we have out there. Tailor it to your specific organization. That's just the biggest hassle here, and Microsoft has some documentation around this. Your service principal has to be registered with PPAC. It's a specialized single-use PowerShell command that is not very well documented. You have to specifically go look for it, but otherwise, Microsoft documentation is pretty good. And also, we're going to be using variable groups inside of DevOps. I highly recommend you use a key vault, but it's not required. For just an example of what a sprint may look like. Again, we've got different actors are delivering different things. They go into a main build. We cut a release from that, and it goes through all of our checks and balances and approval, and then we finally get it out into production. So just another way to look at it. But again, workflow is sort of the main thing here, and we've got independent actors doing just sort of their piece of the puzzle to get everything out to production. So sort of to wrap up, what this delivers, and again, here's the QR code if you want to hit that with your phone, or here's the link, and I'll put this in chat in just a moment. It has everything you need to get this going. And you can get full automation with structural enforcement to get your version artifacts. What this means is zero drift. So same binary, deterministic compilation. So no more guessing, no more uncertainty. We can just use workflow and approve or decline, and we'll get stuff out to production. So I'll open it up for questions.
This is mind-blowing for me. I haven't coded in a while, but coming from a more of a manual process and all this, Nate. So just nice to see these kind of advancements. And I was kind of constantly thinking about, oh, I could see how I do that now, or this is what would replace what I'd done before. What's the time frame for say if you've got a customer, or you're a consultant or a partner, what's the time frame for like troubleshooting? Like I got a customer, they've got a problem, I want to troubleshoot it. I'm not going to do it in prod. So to get the data back to a development environment or environment where I can test it, how long does that take?
So that's greatly improved over LCS. So you can, I want to say hours. I mean, it's highly dependent on your database size. So there's that sort of caveat. Yeah. But we can now go from, let's say, like right this very second, production has an issue. It's a critical blocking issue. We can issue a command to copy production into another environment. And if we have a dev environment just sitting, waiting to go, we can do production to dev right now. So let's say that takes 120 minutes to actually execute. We can go from production problem to dev environment ready to go with debugging capabilities in 120 minutes. Sometimes less if your database is smaller. So if you compare that to LCS, you got to go prod to your sandbox, then sandbox to the next thing, whatever that may be. That's a greatly improved story. So and I didn't even really talk about that because that's now sort of I've fully adopted the PPAC model. Not to say that it's absolutely perfect. It is very much not. But just the flexibility we get with PPAC, especially around our database lifecycle, is much improved. So we can just get what we need from an environment that is presenting with a problem somewhere else, so we can actually tinker with it and start flipping switches and say, okay, well, if I do this, what happens? Does that makes my problem better or worse? And if I've got dev environments sitting around, I can go, all right, well, here's this environment with the code that it's presenting with. What is going on? Can I debug it? What is the actual thing that's going wrong? and get to root cause, assuming you've got a developer on standby, potentially in just 3 hours, which is, potentially huge.
Yeah, I mean,
especially compared to LCS.
Big improvement. When I was at the partner a few years back, it was, we had various customers, so all on different versions. But yeah, I mean, you're talking, probably, we definitely know 3 hours, it's a process to get that, worked through. So cool. I didn't see any other questions in the chat. Beau, did you?
No other questions in the chat, for sure. It's unclear if the recording split your session in half, Nate, but
it did, but we'll pull them together.
Yeah.
Yep.
For me, I loved your 2-job deploy pattern. I think that kind of framework or pattern, for lack of a better word, it could be used everywhere. It's not just for pipelines and ALM, but it could be used for like AI and automation and everything across the board. So I think for me, that was the one thing I wanted to take away and make sure I took notes on, is just like hey, check everything, validate and verify, and then you're good for your release. So making it into like 2 stages is frankly smart.
Yeah, I mean, I'm a huge fan of the trust but verify, especially because like one of the drawbacks of PPAC is Microsoft is in there. They aren't telling us necessarily what they're doing or when they're doing, which is something we just sort of have to work around. So we have to say, hey, Sandbox, are you ready for, for me to issue a command? And it says, no, I'm not. And you say, okay, I'm not going to do it then. I'm going to wait 30 minutes and then check back again. And that's just important because, like a few days ago, I had some dual write updates that were deploying. I didn't know that was going to happen. And they were just happening. And we had to just sit and wait while that was doing its thing. Which is, again, not ideal from, a specific timing perspective, but it's fine. We'll just have to learn to live with it. Usually those deployments go pretty quick, so we're not talking, days. We're talking 15, 30 minutes sometimes. But I guess one thing I did want to touch on, we didn't get any questions on LCS, but I did want to call out, and this is a sort of new development. Microsoft, and I don't recall if it's private preview or public preview, Microsoft is unveiling new functionality around moving your LCS stuff over to PPAC. So you do have to opt in and actually communicate with Microsoft. You can't just start clicking buttons in LCS and have magic happen. So you still have to communicate to Microsoft you want to do this, but there is now a path forward to move your LCS hosted stuff over to PPAC. If you're already in production. It's a process. You do have to work with Microsoft, and Microsoft is actually having someone do an attended sort of movement. So it does fall back to product groups, which don't have 24-hour-a-day support. So you do have to sort of coordinate that with them. But we are seeing Microsoft continue to make steps for LCS to be minimized and PPAC to be front and center. And we still have our sort of known exceptions. LCS is not going to totally go away. We're still going to have some workloads for, like if we have any LBD people on here, if you don't know what that acronym means, that's okay. But we do have local deployments that LCS is going to continue to service, at least for right now, and won't be PPAC centric. So LCS is going to be minimized, but still not totally go away. But for all of our cloud first initiatives, everything is going to be PPAC.
Awesome, man. Well, we appreciate it. Thank you so much, Nate, for being here with us.